Good day to you all. In this video, I'm going to present a physical design of IoT. Uh, Before go through the physical design of IoT, we can know about the things in IoT usually refer to IoT devices which have unique identities and can perform remote sensing, actuating, and monitoring capabilities. Okay. So each and every IoT devices having unique identities or unique identifications because many number of IoT devices are grouped together performing a particular task means the system will be confused for uh, the identifications. So that for each every IoT devices having unique identity. IoT devices may consist of several interface connections to other devices. So this content, the each and every IoT connected to the connected to the many of the interfacing devices, both wired and wireless. These include the first one, I/O interfaces for sensors, input and output interface for sensors. Second one, interfaces for internet connectivity, memory and storage interfaces. And fourth one, audio and video interfaces. So groups of interfaces for IoT devices to other devices. Okay. 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 So, a general block diagram of on IoT devices. So on IoT devices are apply to any one places means this IoT devices having uh, these kind of blocks, these kind of particulars the IoT devices definitely having. Okay, so the first one is connectivity. Devices will be connected to the host and Ethernet. Okay, the IoT devices and graphics card, central processing unit and graphical processor unit. Okay, and also its interfaces not type. Okay, and it's having an audio video interfaces, multimedia interfaces, and 3.5 audio and RCA video cables. Okay, and it's having on storage interfaces ST, SACARD, and MMSC and STO. Secure digital input, and also mainly it's having on communication interfaces to connect the and actuators, etc. The first one UART, Universal Asynchronous Receiver and Transmitter, and second one SPI, Serial Peripheral Interfaces, and third one and fourth one CAN protocols. Okay, so these are all having each and every IoT devices must having. Okay, so these are all general application sizes, home appliances, smart phones and computers, wearable electronics, automobiles, energy systems, retail payment systems, printers, pins, helms, and sensors, cameras. These are all the different IoT devices are available in different fields. Okay, this is the IoT protocols. The will be subdivided into four parts. So first one is link layer, second one is link network layer, and third one is layer, and fourth layer. So each layer having on different protocols and protocols. Okay, so we will discuss each and every communication protocols in a different layers. Okay, the first one is link layer. So link layer protocols determine how data is physically sent over the network, physical layer or media. Local connect to which host is attached. Hosts on the same link exchanges data over the link layer using link layer protocols. Okay, so link layer determines how packets are coded and signaled by the of devices over the main which the host is attached. Okay, so these are all the layer protocols. 802.3 Ethernet. This is IEEE standards 802.3. It's collection of wired Ethernet. It's normally if you are Ethernet port to in our computer or laptops, this is called as a Ethernet port IEEE 802.3. It is used in a coaxial cable. It uses a copper twisted pair connections. This is an all fiber Ethernet cables we are all using for all industries. Okay. So second one is 802.11 Wi-Fi models. This is standard one is IEEE 802.11. Some of the government laptops or some of the laptops, it's not Wi-Fi means we are externally by the 802.11 Wi-Fi models. It will be attached into the in our laptops. It will be easily connected with the Wi-Fi connections. Okay. That's of wireless LAN communication standards, including extensive description of link 802.line. It operates on a 5 gigahertz bands, and it's having on 802.11b and 802.11g. These bands are 2.4 gigahertz band, 802.11 and operate by gigahertz band. So different models, it's having a different operate band area, frequency band. Okay. And third one is 802.16 WiMAX. The IEEE standard number is IEEE 802. A collection of wireless broadband standards. Okay. Including exclusive description of entire WiMAX provide data rates from 1.5 MB per seconds to 1 GB per seconds. WiMAX. Okay. WiMAX communication protocols. 802.15 LoRa app band. This IEEE number is 802.15.1 applications know about the communication protocols. Zigbee. The Zigbee is used in 802.15.4 LoRa app band. Provide data KB per seconds to 250 KB per second. 2G 3 mobile communications data rates from 9.6 KB per seconds 2G to up to 100 MB per seconds 4G data. Okay. So these are all the communication protocols of link layer under the link layer. Okay. This is Ethernet only is a wired communication protocols, and then Wi-Fi, WiMAX, WPAN, and 2G, 3G, 4G. These are all wireless communication models. Okay. These are all under link layer protocols. Okay. So second one is a network and internet layer responsible for sending IP datagrams from sources network to destination networks. It will mainly used for as IP addresses based networks, performs the host addressing and packet routing. Datagrams contain sources and destination addresses. Okay. So network, internet layer protocols. It's classified as a three types: IPv4, IPv6, and 6LoWPAN. Okay. So IPv4, Internet Protocol version 4, is used to identify the device on a network using a hierarchical addressing scheme. 32-bit address allow total of 232 addresses. It's having a 32-bit address allow total of 232 addresses. IPv4 means if you are connecting the Ethernet port in your colleges or company means definitely if you are having an IPv4 and IPv6 protocols, and it's having on um, uh, separate IP addresses for your systems. How put the IP address for your system, correct IP addresses means are able to access the internet. Otherwise, you're not able to access the internet. Okay. So this one, so only difference is IPv4, IPv6 bit addresses and 128-bit addresses schemes in IPv6. Okay. So 6LoWPAN IPv6 low power wireless personal area network operates in 2.4 gigahertz frequency range and data transfer up to 250 kilobytes per second. Okay. And then third one is a transport layer. The transport layer is classified into two types, TCP and UDP. TCP means transmission control protocols and UDP means user datagram protocols. So transmission control protocols, it's all used in our browser like Google Chrome or Microsoft Edge browsers. So all browsers are having an HTTP and HTTPS addresses. So emails along with SMTP and FTP files also below this transmission control protocols are available. Okay. Okay. User datagram protocols is connectionless protocol in a time sensitive applications. Very small data needs to exchange. Stateless protocols. This is also stateless protocols. So and then application layer, fourth one, defines how the applications interface with lower layer protocols to send data over the network. This is classified as different types: HTTP, COAP, WebSocket, MQTT, XMPP, DTS and AMQP. HTTP means hypertext transfer protocols. www dot something, the website will be created. These kind of uh, data will be readed from your system, means these are all come below belongs to HTTP protocols. Okay. COAP, constrained application protocols. This is a machine to machine protocols. Okay. Client to server architecture or server to client architecture. These are all come with a COAP networks. Okay. So WebSocket allows full duplex communication over a single socket connection. WebSocket communications protocols means if you are using a single socket wire or connections, means it will be operated in either direction, both forward and reverse, and also full duplex communications. Okay. MQTT means message queue telemetry transport is lightweight messaging protocols based on publish subscriber model. Okay, it's like what the if you are having a YouTube channel, means your viewers will be subscribed your channel, means he will be notified for that persons will be subscribed in your channel. These are all under below MQTT protocols. Okay, and then XMPP protocols, extensible message and presence protocol for real-time communication and streaming XML data between network entities. Okay, that one of the example is client server and server server communication. DDS means data distribution service, is data centric middleware standards for device to device or machine to machine communication, uses publish subscribe. AMQP, advanced message queuing protocols. It's open application layer. It's where all if you are using anything in business messaging. Okay, supports both point to point and publish subscribes models. So these are all the physical designs of IoT. The physical design, the under block diagrams, if you are understand, and then four IoT protocols layers. These are all the physical designs of IoT devices. Okay, thank you.